Hello everyone. So today our topic is activation energy. This is very important topic for O level, A level, F.Sc, and approximately 1 to 2 MCQs must be from this topic in entry test level examination in MCAT or ECAT. So this is very important topic. Luckily, this topic is included in O level syllabus, A level syllabus, and also in F.Sc syllabus. So what is this topic? Basically, activation energy means the minimum amount of energy required for an effective collision. Minimum amount of, you can say that minimum amount of energy required for to start a chemical reaction. This is also activation energy definition. So in textbook, the definition is minimum amount of energy required for an effective collision. So what is the effective collision? What is the effective collision? Before we discuss the effective collision, we must have a little introduction from the collision theory. So what this collision theory says? For a chemical reaction to take place, reactant must collide with another. Reactant means atoms, ions, molecules must collide with another to form a homogeneous mixture. So collision may be effective or ineffective. Okay. So collision is necessary for a chemical reaction to start. A reactant may convert into the product, or reactant may not convert into the product. So chemical reaction to take place, reactant must collide with another. So there are the two type of the collision. One is the effective collision and another is the ineffective collision. What is the effective collision? Effective collision, if collision lead to formation of product, if the reactant are collide with another and convert into the product, so we can say that this is the effective collision. And if the collision does not lead to the formation of the product, so then it is called the ineffective collision. So I repeat, activation energy means minimum amount of energy required to start a chemical reaction, minimum amount of energy required for an effective collision. So what is the effective collision? If collision lead to formation of the product, is called the effective collision. If collision doesn't lead to the formation of the product, then it is called the ineffective collision. So let's suppose we have an example. Let's suppose we have a molecule A2 and we have another molecule B2. So A2 molecule collide with the B2 molecule and form an intermediate complex. In our case, so here is. So this is called the activated complex. This is called the activated complex. So this is called the activated complex. So what is the activated complex? So activated complex means energy is maximum. So this state have the maximum energy. Maximum energy mean it is the very unstable and short-lived transition state. So that's why this state is called the transition state. Just before the collision, kinetic energy decrease and the potential energy increase. I repeat, two molecules A2 and B2 collide with one another and form a activated complex. So there are the two chances of the activation. First, we remember that the activated complex mean it is a highly unstable. Highly unstable mean it have the very high energy short-lived species. So there are the two chances after the intermediate complex. If the collision is effective, if the collision is the effective, then we get this product. And if the collision is the ineffective, we have same type of the reactant, A2 and B2. So I hope you understand. A2 molecule react with the B2 molecule and form the activated complex. So this is a very short-lived species having very high energy state. So if the product is if the collision is effective, then we have the product AB. If the collision is ineffective, then we have the same reactant A2 and the B2. So this AB represent the activated complex, and this A2 plus B2 represent the ineffective collision. Ineffective collision. So collision is maybe effective, or collision is the maybe ineffective collision. If all collisions among the reactant species at a given temperature are effective, suppose we have a state, if all collision among the reactant species at a given temperature are effective, so the reaction is completed in a very short time. If collision is effective at a given temperature, so all the reactant convert into the product in a very short time. So most of the reaction are, however, slow, showing that all collision are not equally effective. So all collision in maximum time, all collision are not equally effective. So activated complex, so first we define the activated complex. So here is the definition of the activated complex. Activated complex is an unstable combination of all atoms involved in a reaction. Here is a activated complex mean unstable combination of all atoms involved in a reaction for which energy is maximum. It is a short-lived species that decompose into the products immediately. It has a transient existence, and that's why it is called the transition state. So we can also say that when colliding molecule come close to each other at a given time of the collision, they slow down and then fly apart. If the collision is effective, molecule flying apart are chemically different. Otherwise, the same molecule just bounce back. Otherwise, if the collision is effective, we get the AB. If the collision is ineffective, we get the A2 and the B2. The process, so let us understand explain this process with the help of a graph. So which is very important. So we explain this with the help of the graph. Let's suppose. On the y-axis, we represent the potential energy. On the y-axis, what is potential energy? On the y-axis, we represent the potential energy. On the x-axis, reaction coordinates. Reactions coordinate. On the x-axis, reaction coordinates. On the x-axis, we have the reaction coordinates. So we have the two graphs. And maximum MCQs short questions are coming from this graph. Let's suppose we have this graph. So this represent the reactant and this represent the product. So in this case, you can see that product are at the higher energy level state. Product are at the higher energy level state and reactant are in the lower energy state. So we can say that this is a endothermic reaction. So we can say that this is a endothermic reaction. So this graph represents the endothermic reactions. So this graph represents the endothermic reactions. Why this graph represents the endothermic reaction? Because product are at the higher energy level. So endothermic definition is that product are at the higher energy level and reactant are at the lower energy level. So energy absorbed during the reactions. So you must remember these things. So this graph represents the endothermic reaction. So what is the definition of endothermic reaction? Endothermic reaction is a non-spontaneous. Endothermic reactions, we can say that the endothermic reaction is also called non-spontaneous reactions. So endothermic reaction is a non-spontaneous reaction. And for the endothermic reaction, del G value is equal to the always positive. What is the meaning of Gibbs free energy? So G represents the Gibbs free energy. So what is the meaning of the change in Gibbs free energy is positive? It means that product are at the higher energy level. So a continuous source of energy is needed to complete this reaction. This means change in Gibbs energy is equal to positive mean a continuous source of energy is needed to complete this reaction. So I repeat, and this graph represents the endothermic reaction. Why? Because product are at the higher energy level state and the reactant are at the lower energy state. So energy absorbed during the reaction. This is a non-spontaneous reaction. Means we must supply the a source of energy to complete this reaction. So del G value is equal to the positive state. So del G change in Gibbs energy free value is equal to the positive means that continuous source of energy is needed to complete the reaction. This is a non-spontaneous. Non-spontaneous reaction means water is always travel from the higher energy level to lower. So this is a spontaneous reaction example, and water is not move from lower energy state to high energy level state. We have another example to understand this. We have another example. Let's suppose we have a large amount of nitrogen gas present in the atmosphere. A large amount of the oxygen is also present in the atmosphere. So question is that why these two gases does not react with each other to form NO. Nitrogen gas is also present in atmosphere. Oxygen gas is also present in atmosphere. So why these gases does not react with each other? It means because to complete this reaction, minimum amount of energy is required. So at normal temperature and normal conditions, minimum energy is not present. So that's why nitrogen and oxygen doesn't react with each other to form the product. We can also say that there is a triple bond present between nitrogen and there is double bond present between the oxygen molecule. So in order to reaction between the nitrogen and oxygen, we must first break the a triple bond which is present in the nitrogen molecule and a double bond which is present between the oxygen molecule. So first we break the nitrogen triple bond, which is strong bond, and break the oxygen double bond. Then nitrogen react with the oxygen. So it required energy to break the nitrogen triple bond and break the oxygen double bond. Then nitrogen react with the NO. So that's why this is a non-spontaneous reaction. So non-spontaneous reaction, the value non-spontaneous reaction value always the positive. Non-spontaneous value always represent the positive state. So change where you see a sign del G is equal to the positive, it means that this is a non-spontaneous reaction. This is a when we discuss the exothermic reaction, then we also discuss the what is the spontaneous reactions. I hope you understand. So next. So next question is that we have another graph. We have another graph, so I can make another graph. First, we represent the definition of the exothermic reaction. Exothermic reaction in exothermic reaction, product are at the lower energy level. Product are at the lower energy level. So we make another graph for exothermic reaction. So here is another graph. So this represent the product and this represent the reactant. We know that at y-axis we have the potential energy and on the x-axis we have the reactions coordinate. Reactions coordinates. So the question is that this reaction is endothermic or the exothermic reaction. So this reaction, this graph represent the exothermic. This reaction represent the exothermic graph. So what is the definition of exothermic? In exothermic, product are at the lower energy level. In exothermic reaction, product are at the lower energy level. Okay. And in endothermic reaction, we see that the product are at the high energy level. So in endothermic reaction, a continuous source of energy is needed to complete the reaction. In exothermic reaction, no need of the continuous source of energy to complete the reaction. This is a spontaneous reaction. So we can say that this reaction is a spontaneous and the del G in change in Gibbs energy value is equal to the negative. So if you see a sign del G is equal to negative, it means this is a spontaneous reaction. So this is a very important MCQs for MCAT, A level, O level, and ECAT entry test examination. If del G is equal to the negative, it means this is a spontaneous reaction. In spontaneous reaction, product are at the lower energy level and reactant are at the higher energy level. So there is also confusion between the reactions kinetics and the thermodynamics. This reaction is spontaneous according to the thermodynamics. According to the thermodynamics, we also in our lecture differentiate between the thermodynamics and the reaction coordinates. This reaction is spontaneous according to the thermodynamics. Why this reaction is spontaneous according to thermodynamics? Because del G value is equal to the negative, and this reaction is the exothermic, mean product are at the lower energy level. So what represent this? What represent this? We can also explain this. This is a activated complex. This peak represent the activated complex. This peak represent the activated complex. This peak. So here is activated complex. We can say that this represent the activated complex. So activated complex, we said that the activated complex has the highest energy state. So we can say that this is the activated complex. So this value represent the activated complex. We can say that this value represent the activated complex. This value represent the activated complex. So this is, you can see that from this graph, this is a highest energy state. Highest energy state. So we also define this value. So reactant reach the peak of the curve to form the activated complex. These reactant must reach this value to form the activated complex. So activation energy of all activation, it appear potential energy hill. So this is also called the potential energy hill between the reactant and the product. Only colliding molecule with proper activation energy will able to climb up the hill and give the product. If the collision is effective, then it means only collision molecule with proper activation energy. If the collision have the proper activation energy, will able to climb up the hill. If reactant collide with each other and have the proper activation energy, then reactant will able to climb up this hill, form the activated complex, and then convert into the product. Convert into the product. So according to thermodynamics, this is a spontaneous reaction. According to thermodynamics. Why? Because the product are at the lower energy level. But according to reaction kinetics, this is not a spontaneous reaction. Maybe overall this reaction is a spontaneous reaction. So chemical kinetics says that first we provide energy. First we provide the energy to reactant to climb up this barrier, to cross this barrier, and then reactant convert into the product. So we must provide the energy to reactant to climb up this barrier and then convert into the product according to thermodynamics. According to thermodynamics. So what thermodynamics says? Thermodynamics says if the product are at the lower energy state and reactant are at the higher energy state, then reactant spontaneously convert into the product by releasing the energy. According to reaction kinetics, we must provide some little amount of reactant to climb up this barrier, and then reactant convert into the product. So thermodynamics is another, thermodynamics tells another story, and reaction kinetics another story. Overall, this reaction is the spontaneous reaction, and all spontaneous reaction are the natural process, and all natural process proceed with the decrease in the Gibbs free energy. All spontaneous reaction proceed with the decrease in the Gibbs free energy. So here, this is our reaction, our lecture. So all the maximum questions from the graph. So this graph represent the activated. This graph represent the exothermic, non-spontaneous, natural process, and change in Gibbs energy is the negative. So another, if we have another graph, let's suppose this graph. So in this graph, product are at the higher energy level and reactant are at the lower energy level. So this is the non-spontaneous reaction, and then G value for this graph is the positive, and this is not a natural process. In natural process, product are always at the lower energy state, and reaction proceed with the decrease in the energy. So all question from this. So we have another topic, another MCQs basically. So what is another MCQs? For a reversible reactions. In our lecture, we have discussed the forward reactions. So what for the exothermic reversible reactions? For exothermic reaction, energy of activation forward reaction is less for reversible reaction. For we can say the for exothermic reaction. What graph represent the exothermic reaction? In exothermic reaction, product are always at the lower energy state. So in this case, activation energy for forward reaction is less than the backward reactions. And if we move from reactant to product, it means we move from the forward. So we decrease the energy. If we move from reverse, product to reactant, then this reaction become endothermic because reactant are with the higher energy state and product are at the low energy state. So for the forward reaction, this is a spontaneous, and for the reverse reaction, this is a non-spontaneous reactions.